we are going today to talk about biomolecules. And these are molecules that we can use as a fuel source. So these are carbohydrates, fats, and proteins. And each of these different types of fuels are used differently in our body. Okay? Now, I'm going to start out by telling you something. What I'm going to tell you is scientifically proven. If you don't believe me, which is fine, you don't have to, you can get onto a website called PubMed.com, which is where you will find all of the scientific journals that also back up everything that I'm about to tell you. If you still don't want to believe me, then what I'm going to tell you is that you are choosing to believe the U.S. government instead. So you decide who you trust more. It's up to you. So, carbohydrates. These are a group of different types of foods that we eat that would include things like sugar and starches. And carbohydrates come in basically two forms: simple carbohydrates and complex carbohydrates. Now, sometimes you'll also hear people refer to them as simple sugars and complex sugars. The word is really interchangeable with carbohydrates. So we're going to start out talking about the simple carbohydrates first. You have two basic kinds of simple carbohydrates. You have one group that are referred to as monosaccharides. And then you have another, which are the disaccharides. So monosaccharides would include things like glucose and fructose. We also have sugars or carbohydrates like deoxyribose sugar, which is found in our DNA, and then ribose sugar, which is found in our RNA. But this is just a single molecule of a type of carbohydrate. Now, if we want to have a disaccharide, excuse me, we're going to take two monosaccharides and bond them together. So, for instance, glucose and fructose, you bond those two guys together and you get sucrose. And sucrose is, you know, that stuff that you scoop out of the jar and put into your iced tea. It's just regular old white sugar or brown sugar or whatever color your sugar is. This is sucrose. Honey is also sucrose. It's, believe it or not, it's the same exact chemical structure as the sugar in your sugar jar, which is really interesting. If you put two glucose molecules together, you get maltose. If you put a galactose and a glucose together, you get lactose. Now, you've probably heard of lactose because there's plenty of people who genetically are lactose intolerant, which means that in order for you and I to use carbohydrates as an energy source inside of our cell, they have to be in the monosaccharide form. Each individual molecule has to be separate from the other. So if I want to use lactose, which is a milk sugar, if I want to use that as an energy source, what I have to be able to do is I have to be able to break this bond right here. And there's certain chemicals that our bodies make that allow us to break that bond unless we're lactose intolerant. And lactose intolerant means that these people cannot make certain chemicals to break this bond. They cannot use lactose as an energy source. So then what happens, unfortunately to them, is that the lactose stays in their stomach and in their small intestine and starts to ferment. And it kind of gets a little bubbly and things start kind of excreting in different places, and then it sort of makes everything slippery inside and it comes out really fast the other end. And yeah, it's not a really fun thing to have. Lactose intolerance, you don't want to be eating a lot of milk products or dairy products. Now, there are some dairy products now that they say a person with lactose intolerance can eat, and that's because they add to this product the chemical that breaks this bond. And it works fairly well unless you're really super duper lactose intolerant. Then you might as well start drinking coconut milk or almond milk and leave this dairy stuff alone, because it's just not a fun time for you. Now, the only thing I want you to memorize as far as these chemicals are concerned is sucrose, because we eat a lot of it, so you should know that it's made up of glucose and fructose. That's really important. By the way, maltose, this is what you get in what's called malt, or it's also found in wheat and barley. These are just big glucose molecules, also found in corn. All right, now the next group of carbohydrates are the complex carbohydrates. These are also called polysaccharides. Now, polysaccharides are all made up of the same type of thing. They're a huge molecule, so this is the polysaccharide right here. This is a big molecule, and each one of these little dots represents a glucose. So polysaccharides, these complex carbohydrates, are made up of hundreds of glucose molecules all bonded together. And they all have this kind of funky branching chain-like pattern also. So it's not just like a straight chain or a circle or something. You get these really weird, intricate shapes as well. Now, in our body, we can store polysaccharides as an energy source. And we store this polysaccharide in our liver and in our muscles. So it's kind of like, you know, you have a second gas tank on your vehicle so that you can go a little bit further, a little bit longer, and you get this storage in the liver and in the muscles. And this type of polysaccharide is what we would refer to as glycogen. Now, we call this polysaccharide glycogen if you're an animal. Any kind of animal, bird, reptile, primate, doesn't matter. All animals have this polysaccharide storage ability in their liver, in their muscles, called glycogen. But plants can store it too. And when plants store this polysaccharide, we refer to this as starch. So for instance, corn, really good at storing polysaccharides. We say corn has a lot of starch. Or potatoes, super good at storing polysaccharides. So we say potatoes are full of starch. Okay? So this is a type of complex carbohydrate. And complex carbohydrates, okay, now here's what they're really good for as far as the human body is concerned, and you all already know this. They are super good to give you a short-term, really high boost of energy. That's what they're all about, and you know that, because if you need a good boost of energy, you eat a candy bar, which is just packed with carbohydrates. It's packed with sugar. Okay? Or if you need a really good boost of energy, I mean, you drink a sweet soda or something and it gets you all hyped up. You've probably, you know, if you have kids or nieces or nephews, you've probably seen what kind of boost of energy a pack of M&Ms does for them. They're like bouncing off the walls, okay? Because that's what carbohydrates do for us. They boost our energy very, very rapidly, okay? And they get us up and going. The only problem is carbohydrates don't last long. They're not a long-term energy. They're a short-term, rapid type of energy, okay? And here's the other problem. If I eat a lot of carbohydrates, okay, and the American diet is just packed with carbohydrates, okay? If you go to Europe or, you know, some other country, they don't eat as many carbohydrates as we do, okay? You go to France, for instance, and they're big in eating vegetables and eating meat, but they eat very few carbs. They eat a little bit of bread, but that's pretty much it. If you look on all the packages of food that you buy, it is full of carbs. Any packaged food you purchase in the supermarket, besides like meat and vegetables, they're just packed with carbohydrates. And carbohydrates, again, keep in mind, it's for rapid boost of really quick energy. And if I eat tons of carbohydrates all day long, if that's my major source of food supply, I may not need all that energy, especially like you're sitting for, 4.5, 5 hours in physiology class. You don't need a lot of energy. You're not moving around. You're not running all over the place. So if I'm eating carbs all day long and I'm also sitting all day long, what the heck does my body do with all that excess energy? Well, we have something in the body that we refer to as de novo synthesis. And what this means is our body can take one kind of a chemical and turn it into something totally different. And so what do you think our body does with all those excess carbohydrates if we don't need all that move around, get up, run around energy? Turn it into fat, exactly. So we can take any excess carbs we don't need and we can store that energy away as fat. Because see, here's what happens. The body goes, oh, well, she's in control here, and she's eating like 10 candy bars today, and also like a bowl of ice cream, and then a whole bunch of potatoes and corn chips and all that kind of stuff. She must know something, like there's a famine coming or something. So maybe we should store away all this excess energy that she's putting into the body, and we'll just store that away in very, protruding places. And so when a society eats a tremendous amount of carbohydrates, all you can assume is that either the society moves a lot or the society is fat. And when you look at other societies outside of the United States, they don't have the obesity problem that we have here because we eat so many carbohydrates. Now, what you have been taught is that if you eat too much fat, fat will make you fat. That is not true. If you eat too many carbohydrates, carbohydrates make us fat. We're going to talk about fat in a little bit and how our body utilizes it. But carbohydrates are the leading cause of obesity in the United States. One of my son-in-laws is from Ireland. He lives in Dublin and with one of my daughters. And he loves to come to the United States and take pictures of people. And what he loves to do is find the fattest people he possibly can and snap a picture of them. And he has a fat album. And I'm just like, David, why do you do this? He goes, because there's no fat people in Ireland. I'm like, oh, please, give me a friggin' break. So, of course, I have to go over to visit them. We're in Ireland, and he's driving us all over the country. And we stop at this little pub to get something to eat for lunch. And we're getting out of the car, and I'm like, look, there's fat people over there. I told you there's fat people in Ireland. He goes, no, they're Americans. And how in the world do you know they're Americans? I know, they're Americans. There's no fat Irish people. So we walked over. Sure enough, they were from New York. And you don't see obese people. It's just not something that you find in Europe because they don't eat the type of carbohydrate load that Americans eat. And it's because we grow a lot of corn. And when our farmers grow so much corn and the government pays them tremendous amounts of money to grow even more corn, what the heck are you going to do with it all? So we feed everybody corn. We feed you corn, we feed me corn, we feed the cows corn, shoot, we even feed the fish corn. Okay? So all of these excess carbohydrates, we know through de novo synthesis, allow us to pack on the extra weight. Are you looking for? Now, one of the other problems, and we talked about this on the first day, on Monday, is that sugar, okay, which are our carbs, also acts kind of like a scouring pad on the inside of our blood vessels. So one of the things you've also learned is that high levels of cholesterol clog your arteries. And yeah, that's true. That is actually very true. However, how the heck does this slippery cholesterol, cholesterol is sort of like butter, it's very slippery. How does this slippery cholesterol stick to the inside of arteries that are supposed to have a slippery layer like Teflon surrounding them? How could that slippery cholesterol stick to the slippery Teflon lining of our arteries? It can't. It doesn't have the ability to. So something has to scratch the walls of our arteries first to allow things to stick to it. And what scratches the walls of our arteries are the carbohydrates. When we have very high sugar levels continuously all day long floating around in our carbs, because our arteries, you're eating carbs for breakfast and for lunch and for dinner and for snacks, and so the carb levels are high. Those high sugar levels constantly in the arteries are ruining the walls of your arteries. And now platelets stick, cholesterol sticks, all kinds of different things stick. So now let me ask you this. If you're the doctor, you're the physician's assistant, you're the nurse practitioner, and you're talking to your patient about how they may have clogs in their arteries, is it legitimate for you to just say to them, you need to lower the cholesterol levels in your diet? Is that all you should say to them? Lower the cholesterol levels in your diet? Absolutely not. Yes, you have to also tell them they have to lower the carbohydrate levels in their diet. Because if you lower the amount of sugar, the inside of the arteries will have time to heal. They will regrow, they can heal, but not if you keep ingesting massive amounts of sugar all the time. And that's the problem with the patients. Now, let me just stop and tell you one other thing. I know how you all are, okay? You're going to be nurses, and you're going to go into the medical field and be different professionals. And you're kind of like gardeners, you know? The gardener goes out, he cuts everybody else's lawn, and never takes care of his own, okay? So I'm cool with the fact that the likelihood is you won't take care of your own body, but make sure you're telling your patients the right thing. It is not all about high cholesterol levels in the diet, it's all about high carbohydrate levels. So you have to tell your patient that they need to lower their carbohydrate levels. And that is not easy to do. Because if you go through the grocery store and you go, let's say you go through the fruit and produce aisle, and then you sort of go through the back where all the meats are, those are the only aisles you should be shopping at in a grocery store. All that stuff in between, everything in between, are carbohydrates. Everything. And so when you're going up and down those rows, there are very, very few items that you will be able to find that aren't super high in carbohydrates. The average American eats anywhere from 5 to 1,000 grams of carbohydrates a day. The average adult American. What is a healthy amount of carbohydrates in a day, Kristen? How many grams would you suggest?
I would suggest 20 grams to maybe 50 grams.
And we're eating anywhere from 5 to 1,000 grams, and below 100 grams is recommended. No wonder we have such cardiovascular disease in the United States. And no wonder that 1 in 2 children who were born this year, by the time they are 12, will have diabetes. 50% of our children's population, by the time they're 12, will have adult onset diabetes. That's horrifying. That means 50% of this country will be deathly ill in 12 years. Or 50% of the future adult population of this country will be deathly ill. That's seriously, seriously horrifying. And all we're telling people in the news is don't eat cholesterol. And we're not saying anything about the carbohydrates.
Have you worked in the keto diet?
Yes, I have. Yes, I definitely have. Kristen, how much weight have you lost on a ketogenic diet?
14 pounds already, and I started April 27th.
Yes. We'll be talking
And
about
I've
that,
done
and I'll
zero
also be
exercise
handing
over
out.
hours. I don't work out.
Exactly.
Just no sugar, no starches.
And
It's
lots
good,
of
though.
fat.
Lots of fat.
How about like eating like brown rice?
Rice is a carbohydrate.
Still a carbohydrate.
It is still a carbohydrate. Now, here's the nice thing besides brown rice versus white rice. Brown rice has fiber in it. So what happens is sugar will stick to fiber as it floats through your bloodstream. So it will not scrape the walls of the arteries as much. So if you have to eat rice, your best bet is the brown rice because it will lower the amount of sugar in the system, but you just don't want to eat a lot of it. You want to eat very little. And if you want to lose weight, you don't want to eat any.
Is fruit carbohydrate?
Yes, it is. Fruit is fructose. It is a carbohydrate.
What are you gonna eat?
What are you going to eat?
Meat, cheese.
The same thing your parents used to eat. Meat and vegetables. Yeah.
The potatoes.
You can have potatoes every once in a while. You can have, but everything in moderation. Not the way that we eat. We eat far too much. We eat far too much of the wrong thing. Any questions so far? Or any more questions? All right, so let's talk about lipids. Lipids are fats, okay? So the question is, if I'm not eating a lot of carbohydrates, what should I eat? Well, the only other options you have are fats and proteins. Because remember I told you there's 3 molecules we use for energy. Carbohydrates, fats, and proteins. And here's the problem with diets, okay? So you're going to have your patients who are coming in. Many of them are going to be obese. We know obesity is bad because it harms the body, okay? So we want to get our patients on a good diet. But here's the problem, okay? You say to your patient, go on a healthy, low-calorie diet. Well, number one, they're obese, so they don't have a clue what healthy means. Okay, so you can't tell them to be healthy without explaining this to them. They don't understand it. Number two, the minute you tell your patient to go on a low-calorie diet, their brain starts freaking out. Because here's what our brain says. Holy crap, we're in famine. Oh my gosh, what are we going to do? She's not going to eat as much anymore. This is horrifying. Okay, I know what to do. And the brain starts saying, eat, eat. You ever said to yourself, I'm going to go on a diet? 5 minutes ago you weren't thinking about food, but the minute you said, I'm going on a diet, you found yourself mysteriously inside the refrigerator eating everything there. You're starving, okay? Because the brain is flipping out that it's not going to have enough calories to power the body. So you cannot simply tell your patient, eat low-calorie, healthy food. They're going to look at you and go, I can't survive. There's no way I can survive. Because they're going to start to starve. You have to substitute. If you tell them to drop their carbohydrates, you have to tell them to raise their fat and protein level. And that seems totally wrong. Because what you and I have been taught since the 1970s is that fat is bad. It is bad, it is bad, it is bad. And that is absolutely 100% wrong. The body needs fat to survive. It's part of who we are. We as humans use fat as a long-term fuel source. So carbohydrates are quick energy, but fats are for the long run. So what you're doing pretty much all day long, sitting, walking slowly, not really exercising, sleeping, all the things we do all day, you're actually burning fat. That's when we do most of our fat burning, is just the all-day stuff. Which also means you require fat to keep moving. Now, our brain prefers to work off of fat. That is the fuel source the brain prefers. But when you see people who are eating a very low-fat, high-carbohydrate diet, one of the problems is they start to get that kind of brain fog. They're not thinking real straight. They're super tired all the time. They start to feel like they have some memory issues. I can't memorize things. I can't remember things. It's because the brain is not working at its peak performance. The brain only works well when it is given enough fat. Now, there's a balance between the brain needing carbohydrates, absolutely, but the brain also requires a fat source. So if you have someone on a super duper low fat diet, there is actually a possibility of that patient going into a coma because the brain cannot function without a certain amount of fat in our diet every day. So you have to be able to provide fat. Now here's what I'm going to tell you. As long as the fat is considered a healthy fat, not the kind you think, the fat is a healthy fat, your patient can eat as much of it as they want.
Healthy fat like.
And they will still lose weight.
What?
Like anything that comes from an animal, so animal fat, milk fat, real butter, anything that comes from a fatty plant, which would be like coconuts or olives.
Avocado.
If you can, or an avocado, if you can squish them and get oil from them, that is a natural oil. So you can squish olives, press olives, and get olive oil. But you cannot press corn and get corn oil. I don't know how many times you've eaten corn in your life, but I'll bet you not one time was that corn oily. Corn oil is not a natural oil. As a matter of fact, you have to put corn through multiple different chemical processes to force it to turn into an oil. If you have to do that, it is a no-no. You should not eat it. So corn oil, canola oil, all these other oils that we have artificially produced and now lie to you and tell you that these are the best oils for the body, all of a sudden cardiovascular disease is up and obesity is up and health is not good.
How about the olive oil? Olive oil.
Olive oil, you can press olives naturally and get oil from them. So yes, olive oil is fine. It is a good oil. And by the way, these are saturated fats. Not unsaturated. They are what we call saturated fats. You are told by your, God bless America government, that you should only eat unsaturated, or what we would even call polyunsaturated fats. These have been shown through many scientific experiments to be the worst fats ever for the human body. By the way, I don't know if you all have dogs, but one of the problems nowadays with dogs is that many dogs are obese. What's the #1 ingredient in dog food nowadays? Unless you buy the really expensive stuff. Corn. And obesity in dogs is up. And you know what else? Cardiovascular disease in dogs is up. Now how weird is that? Because I know your dogs aren't eating candy bars. But they're eating a lot of carbs. Alright, so let's talk about saturated versus unsaturated fats. What the heck are these? How do they work? Alright, so one type of fat, and this can be saturated or unsaturated, but one type of fat that we need to talk about is called a oops, I can't spell today. Triglyceride. which is called glycerol. And then it has a region right here, which is an acid. This is actually, well, we'll just call it acid for now. And this region with the acid and these carbohydrates are often referred to as the fatty acid chain. Okay? Now, I didn't draw it very long, but these fatty acid chains are usually super long. Lots of carbohydrates. Can be up to 121, 122 not carbohydrates. I keep saying that. 120, 122 carbons long. So these can be super long chains. Each chain will have the same number of carbons. If, let's say, you have a triglyceride where the chains are 111 carbons, you have another triglyceride where the chains are 118 carbons, these all have different names. So sometimes you'll hear a triglyceride called something like an omega-3 fatty acid, or an omega-6 fatty acid, or you might hear something like linoleic acid. These are all the different names we give to the triglycerides depending on how long their carbon chains are, okay? So an omega-3 fatty acid, which I'm sure you've heard of before, this is a kind of triglyceride, all right? Now, each one of these carbons in the chains that I've drawn, they all have hydrogens all around them. So this would be the same thing in all three chains. So if we're talking about a saturated versus an unsaturated fat, a saturated fat, if you look at the carbon chain, each carbon has 4 bonds, single bonds, all the way around it. So what I've drawn here, this would be considered a saturated fat. Now, saturated fats are the types of fats that we find naturally, okay? So saturated fat would be the fat that you would get on a piece of steak. That would be considered a saturated fat. Oil that comes from a coconut, that would be considered a saturated fat, okay? Now, saturated fats they're solid at room temperature. So if you're not sure, okay, room temperature again about 75 degrees Fahrenheit, not like room temperature at our house that's like maybe 110 right now. Okay, so 75 degrees coconut oil would be solid, okay, or a piece of fat off of a cow would be solid at room temperature. So here's what has been told to people for a long time by the government is that if it's solid at room temperature at 75 degrees, the likelihood is it will be solid in your body. However, I'm going to challenge you to get some butter and heat it up to about 98.6 degrees, and I'm going to bet your butter melts. Because when we heat these solid substances, these saturated fats, up to body temperature, they melt. So they're not going to be solid inside your arteries. It doesn't happen. We don't open people up after they die and find solidified fat inside their arteries. That does not ever occur. So you will not get butter hardening inside your arteries. Okay? That's not what hardening of the arteries means, which we'll talk about a little bit later. So this type of saturated fat does not cause this type of problem. But let me show you this. Well, let me write it like this first. I want you to know this saying, like dissolves like. Now, again, you already actually know this, okay? If I were to take some olive oil and I were to drop that olive oil into a glass of water, would the olive oil dissolve into the water? No. Fat and water don't mix, right? Okay. But if I were to take olive oil and dissolve it into melted butter, would they mix?
Yeah.
Yeah, because fat and fats mix. That's absolutely correct. Now, look at the overhead just for a second, and notice all, of course, the carbons, hydrogens, oxygens in our triglyceride here. Okay, and I forgot to tell you, the reason we call it tri is because there's 3 chains, obviously. Anytime you see these carbons, oxygens, hydrogens, know that the bonding in this molecule is a non-polar covalent bond. So our fats give us a non-polar covalent bond. So when I say like dissolves like, I could also say non-polar dissolves in non-polar. Or I could also say fats dissolve in fats. Could I also say polar dissolves in polar? Absolutely. By the way, ions, they're kind of sort of polar, you know, with that positive and negative thing, which is why stuff like salt can dissolve in water. Okay? So ions also can dissolve in polar substances. So now here's the reason I have you memorize this like dissolves in like. Because when your patient has any type of clog in their arteries, you need to tell them to eat less carbohydrates and eat more fat, because the fat will dissolve the clogs out of their arteries. Well, we are told absolutely the opposite, aren't we? We are told that fat causes the clogs in the arteries and that carbohydrates have nothing to do with it. But the science states absolutely the opposite. Now, of course, the types of fats that you have to tell your patient to eat are the healthy fats, and the healthy fats are the fats that nature makes, which, by the way, are also saturated fats. It's quite weird, huh? You wouldn't think that that's absolutely the case, but it is. Matter of fact, one of the things that we see, for instance, look at people who are Inuit or Eskimo. They have the lowest rate of cardiovascular disease of any kind of people in the world. But the majority of Inuits, and I know quite a few of them, are actually pretty obese. But they have super duper low cholesterol, clogging problems with their arteries. But they eat a lot of natural fat. A lot of types of fish fat. They eat whale blubber. They eat seal fat. And let me tell you, I've had some of that. Oh my goodness, is it yummy. You cook it on the spit like a marshmallow and, oh, to die for, okay? But here's one of the problems, okay? At my house, we fight for the biggest piece of fat on the steak. And most of you are like, oh, that's so disgusting. But see, I also raise my own cows. And my cows are also grass-fed. They're not fed like the cows that we have to eat at the regular grocery stores that are corn-fed. And the fat on those cows do taste absolutely disgusting. Okay? When we cook a steak at my house, there isn't an ounce of fat left. You eat that first. And then it's like, oh, okay, I'll eat the rest of the steak now because the good stuff's gone. It tastes completely different. Completely different. It's like melt in your mouth, yummy, good stuff. And it's hard to get, it's hard to understand when you buy a steak at the grocery store. And even if you think you're paying really good money for a really good steak, and then you eat some of the fat and go, ugh, I'm going to spit that stuff out. It's so disgusting. It's because we're also feeding our cows corn, and they're supposed to be eating grass. And it completely changes the structure of their meat. As a matter of fact, the Inuits, they eat a lot of omega-3 fatty acids. This comes from the certain types of fish that they eat. All of the fish they eat are wild fish. They're not farmed fish. And they also come from the Atlantic Ocean. If you are going to eat a lot of omega-3 fatty acids, you cannot eat any type of farmed fish, because they feed the fish corn, and the fish now have 0 omega-3 fatty acids. It completely changes the structure of the animal, and they don't even have omega-3 fatty acids anymore. And of course, it's very difficult nowadays to get any kind of fish that isn't farmed fish. And please don't eat any fish in the Pacific Ocean. They're probably radioactive. Ask specifically, can I have unfarmed Atlantic fish? And they will have the highest levels of omega-3 fatty acids. Now, of course, if you can't get a hold of those, in California it's actually pretty hard to do, and you want to have a lot of omega-3 fatty acid in your diet, you can take what? Fish pills? Oh, no, don't take those things. They're terrible. You want to take some cod liver oil. And the reason I don't take don't take fish pills is because they don't refrigerate them. And if you've ever taken those, you take those fish pills and then you burp fish all day. That's because you're taking rancid fish oil. It's already gone bad. So if you're going to take fish pills, you've got to find some that are refrigerated. But I highly recommend don't take that. Just take cod liver oil. As a matter of fact, like at BJ's down the road, they have a cod liver oil that's refrigerated. And it also has lemon in it. And you cannot taste the fish at all.
And it's not made in China.
It's not made in China. Yep, not made in China. But we're going to talk about this a few times in this class too. One of the things I think is interesting is you have a lot of wives' tales that are really super duper true. And when I think about cod liver oil, I mean, growing up, my mother used to give us like a tablespoon right before we went to bed every night. It didn't have the lemon in it, so you could taste the fish. It was like a beautiful thing to fall asleep to. But you know, it's supposed to be really healthy, and everybody believed in taking a tablespoon of cod liver oil every day. And my question is, how the heck did they figure this out? And I mean, we've known about this for centuries, that cod liver oil is very good for you. How did they figure to take a cod, okay, and then take the cod's liver, and then press that liver and get oil from it, and then that oil from that liver would make you healthy? Who the heck even thought of that? It's the weirdest, most interesting thing that they figured out that this stuff was good for you. And it is. It has some of the highest sources of omega-3 fatty acids, which are the best fats to act like Roto-Rooter, you know, to clean out your arteries. And even nowadays, many doctors, cardiovascular surgeons, are recommending that their patients take cod liver oil to help to clean the clogs in their arteries, because that type of fat will dissolve the fat out of their arteries. And by the way, you've probably heard of HDL and LDL. You know, there are two different types of cholesterol. And HDL, called high-density lipoprotein. LDL is low-density lipoprotein. HDL is supposed to be the good guy, okay? Doesn't stick to your arteries, helps to clean your arteries, gets rid of the bad guy, who is the LDL. There are only two ways to raise your HDL levels. One, I think for Americans is probably a sin. It's called exercise. Okay, so your patient probably will not do that. But that will raise your HDL levels. Two, the only other way to raise your HDL levels is to eat saturated fat. Now, HDL, this type of cholesterol, does not stick to your arteries. So if we're telling our patients, don't eat as much saturated fat, they will make more LDL, which is much more likely to be able to stick to the walls of their beat-up arteries. We've done everything seriously backwards.